This is Jane Low. I'm here on site at Metropolis Innovation Hub here in Singapore at Newman Cyber Technologies. And with me today, I'm very pleased and very privileged to have Dr. Simon Seah, who is a Web3 security researcher with Newman Cyber Technologies. And he's going to be sharing with us some of the latest insights that he has on how to think like a hacker, which is, I believe, a presentation that you were going to present at the Singapore FinTech Festival. In your presentation, I believe that you talk about how some of the Web3 cyber threats, right, are comprising of some of the Web2 threats that we see. So, for example, like DDoS. But there are also specific sort of emerging Web3 cyber threats as well. And if we could start with, for example, the public blockchain cyber threats, right? You mentioned some interesting names like alien attacks, Eclipse attacks, Sybil attacks. Can you tell us what these mean?
Okay. Cyber attack is very often attack things P2P network. That means if a hacker can make his credentials or some certifications with his technology measures, and to make himself have many nodes in the P2P network, and this node which have fake credentials can connect into the normal P2P network and make some attack or make some fake vote or make some fake RCP messages in these P2P networks. So in a word, cyber attack is a fake credential attack in P2P network.
So, for example, well, I have obviously never conducted a Sybil attack before, but if I want to do it, if I understand you correctly, I will create several fake profiles of myself, but obviously not using different names, not right?
Yeah.
And then I form a majority, but actually these are bots of myself.
Yeah.
So it's sort of like a bot network, isn't it?
Yeah. When the hacker has the fake proof of himself, he can do anything in the P2P network, because the P2P network is equal network. Every node have same access right in these networks, messages or networks data. So if we make many nodes, and the hacker have the more authority in this network, he can do anything. Just like this attack is the basic of many attack method in the P2P network, and the 51% attack and the Eclipse attack is all based on the Sybil attack.
Oh, right. Okay, so the Eclipse attack is like a subset of the Sybil attack.
Yeah. If the hacker have many nodes in this P2P network, he can send some fake message, wrong message, just like in BFT network. Maybe
Byzantine fault tolerance network.
Yeah.
Okay.
If he have 1/4 nodes in the
25%, you mean?
Yeah. 25.
Right, okay.
Sorry, 25% in this network.
Right.
He can send a wrong message to make the all system have to do some wrong things. So he can control the network. Maybe he can control some of this network. Maybe there are many other strong nodes all over the world, but cyber attack, and he can make normal nodes cannot connect other nodes.
And so, this is an Eclipse.
Right. This is an Eclipse
okay.
attack, just like Eclipse, right?
Yeah. So how you talk about 25%. So essentially, if I want to launch such an attack, I need to have 25%. I need to have 25% of the nodes in the network, right?
Yeah.
So I would presume that in larger networks like Bitcoin or Ethereum, it's not going to happen because it's going to be very expensive. So we're talking about very, very small networks. So it realistically is the damage is very small, is it?
Yeah. But besides BTC, Bitcoin or Ethereum, many public chain face these threats.
Yes.
Because they maybe have a lower number of the nodes.
So the smaller networks are the where the value is very small. Then but on the other hand, if the value is very small, the hackers are not going to be interested in hacking it, are they? Or perhaps as an experiment, they might try it, but not essentially to steal. There's not much to steal from.
Maybe hacker is not interesting in this network, but their competitions is interesting to do these things.
I see what you mean. Okay, right. Okay. And then you talk about also smart contract vulnerabilities. And I think the question I should have raised in the first hand is, if we look at Web 2 versus Web 3, and we talk about programming languages that's used, how different are they, and why is Web 3 smart contracts more vulnerable to being hacked? Because I see a lot of similarities in some people use Java in Web 3 as well. Yeah.
Java is the most popular language in Web 2. The common language in smart contract, like Solidity in EVM, Rust or C++ in Wasm, that means WebAssembly, like Golang in Fabric, they call it chain code. They all have been often used. And recently, the Move language is becoming more popular in smart contract developer.
Move language?
Yeah, Move language is it's a language that develop the smart contract in Libra, Aptos, and Sui. So Solidity is like a C++6 version. It's very flexible, but you must take care of your code. Some careless code will make the memory leaks, make the stack overflow. So you must be careful of the memory manager in Solidity, just like in C++6 version.
Okay.
Right? But they are very flexible. That's led to less secure code. There's no tools to make your code more secure. That's just the developer can make the code more secure.
So there's an argument there that when, say, C++ version 6 or Solidity language is been pushed out into implementation, perhaps there was not enough security review before it was being pushed out. Okay.
Yeah. So Vitalik said he want to make Wasm or WebAssembly into the next generation of Ethereum.
Oh, right, okay.
So maybe Solidity will be the history of the smart contract, but now it's most popular smart contract language.
So, okay. And then one of the sort of highest high-profile kind of hack that people always mention, or vulnerability that people mention, is re-entrancy, right?
Yeah.
So that is obviously, we see it in the DAO incident back in 2016. For our listeners who are not too familiar with this re-entrancy and the DAO incident, can you explain to us what happened there?
Re-entrancy is the most. Re-entrancy is the oldest vulnerability in smart contract. It happens in 2016.
Yeah. Yes.
And it's led to the Ethereum community to separate into two parts. One is the ETH and one is the ETC. In principle, the reason is Solidity language mechanism. In Solidity language, you can make unlimited cursive. So hacker can call function, and in this function he can call another contract, and another contract can call back to this function again. This is unlimited cursive.
It's calling itself multiple times.
So he can call again and call again. If the number of state compute after the recall things happened.
The balance that was updated happened after. Yes.
Maybe the balance or the state value can be changed before the recall happened.
Yeah.
So this maybe make the smart contract suffer the balance loss, or hacker can withdraw all of the money.
Yeah, so if I get you right, so basically there's a recursive call, but in the DAO incident, what happened is that the hacker execute the recursive call,
Yeah.
but and withdraw the money, but every time after the withdrawal, there was no balance update such that the recursive happens again without knowing that the balance is slowly being drained.
Yeah.
So eventually, I guess the whole thing just collapsed because there's no more balance and the call just as it is.
Yeah.
Is that what happened?
Yeah, you are right.
Oh, right, okay. So, so we talk about this Sybil attacks, we talk about the smart contract attacks, right? And then if I think about like some of the, for example, other sort of incidents in the Web3 world, like cryptocurrency hacks or wallet hacks, right? The common sort of entry point for hackers is, say, social engineering or phishing, right? You get the user to click on a phishing link, and then they come in, drop a malicious code, and then drain the wallet or the exchange.
Yeah.
But then with Sybil attack or smart contract exploits, what do like users like myself have to be aware of? How can we protect ourselves? Because with social engineering, we kind of know from talking to people to say, don't click on links, right? But with Sybil attacks or smart contract attacks, is that something that we can do, or there's nothing we can do?
Yeah. You make an interesting point. You mentioned that some people may click phishing links and download some Trojan from hacker service, and the hackers can control his computer.
That's right.
This attack is often happens in wallet attack. Many hackers make phishing links, and the wallet user maybe click download the Trojan, or make a wrong approved transaction to the malware contract. This often happens in users' wallet attack. This is a traditional Web2 attack, but it also efficient in Web3. And in Web3, there are also some special method used for this attacker. They can just attack the smart contract directly. They just maybe he found some vulnerability in the smart contract. He can just make a transaction like reentrance. Yeah.
So he make a transaction to call the contract and exploit the vulnerability.
Yeah.
Okay.
And some hackers want maybe deploy his own malware contract on the chain, and when he want to attack something, he can call his own malware contract.
All right.
Yeah,
Okay.
his own contract will attack other contracts, and some people make a private transaction in some private transaction platform like Flashbot to make a like sandwich attack in some DEX platform.
So you're saying that there are some potentially malicious contracts that live on the chain. I guess the question is how do the community who use the chain, what can we do to to defend ourselves against this kind of potential threats?
I think be careful. Just be careful.
Okay.
The developer of the smart contract must be careful, and the user also must be careful.
So basically, any contracts that, say I'm a developer, I deploy a contract, I have to make sure that it goes through appropriate sort of audit reviews to make sure that there's no holes for hackers to come in and attack my contract.
Yeah, in security area, we have a word. No system is security. So the developer must take care of his code and make his smart contract to be audited by some third-party security companies, and do more tests in test network and make the vulnerability maybe not more significant in his smart contract. And the users is also must be careful of all his transaction, and the wallet. The wallet provider is also must take care of users' assets. So they must be the first gateway to make the user not face to the hacker directly. The wallet provider must provide some secure mechanism to users to avoid phishing, avoid scam, and to avoid anything which can make the users lose money.
Right. If we look at, say, for example, the top 3 sort of incidents in the last 1 year, people talk about the Poly network, right? The Axie Infinity hack, right?
Yeah.
Maybe Parity Wallet, which was it last year? No, I think that was quite some time ago. I cannot remember. But these, I think in a couple of cases, it's about abusing the access rights, isn't it? And then in the case of Axie Infinity, it's about stealing the keys of the validators. So some of these techniques, I guess what I'm trying to say is they are quite traditional classic methods of hacking. So basically, you break into a secure network, basically, whether it's stealing the keys or abusing access privileges. So is that what you are also referring to when developers, when they deploy, their network, they have to ensure that the security in securing the keys are robust, or the access management is being audited and reviewed?
Yeah. Many of the cross-chain breach like Poly network, some multi-sig wallet like Parity, most of these hack is caused by the leak of maybe some private key of validators. But in Parity events and in Poly network events, it's the vulnerability in his smart contract.
Correct.
And the hacker it's like Web2's injection. In Web2, there are the circuit injection attack in some website, and if the website do not verify the maybe users' comments or users' upload files, it may cause a circuit injection, and the hackers can get the authority or get some rights to access his servers, his database.
Correct.
And in Web3, the hackers make his transaction, and he construct some bytecode in the arguments, which is provided by the function in the original smart contract. And the smart contract do not verify the arguments and do not verify the bytecode's feature. And so the wrong bytecode or the constructed bytecode can call the unexpected contract and maybe get the owner authority or get the admin authority in the contract and control all the system.
Yeah, I see what you mean. Yeah, so it's kind of, it's not quite like a Trojan horse, but it's hiding sort of malicious arguments, instruction in behind some normal-looking instruction, right? Okay. So we talked about threats that we can see in the Web3 world. We talked a little bit about the Web2 world, and you talked about what we as users have to do. Basically, just be careful.
Yeah.
And you also talk about developers need to get their code reviewed properly, audit properly, independently reviewed. So for our audience out there, any advice as to you can give as to how more sophisticated the threats will look like, and what more should they be aware of?
I think the developer can use OpenZeppelin library. It has been audited many times.
So open source library, is that what you're saying?
Okay. Open library developed by OpenZeppelin.
Oh yeah, right. Yeah, right. Okay. So use that one as much as you can.
Yeah.
Is that what you're saying? Okay.
Yeah.
But on the other hand, I think it's a separate conversation for another day. On the other hand, there's an argument that because it's open library, the hackers have a lot of time to, go through the libraries and the code and search for problems, right?
Yeah.
But I guess that's a conversation for another day.
Yeah, maybe.
Right, okay. So, yes, one last thing that I'm quite interested in, but I don't think that we have the time. You also talked about dark forest. And very quickly, just for our audience out there who's not aware of the front running on the dark forest, what do they need to, what is this and what do they need to watch out for? There's nothing they can do, is there?
Yeah, there's nothing we can do.
Right, okay.
I think if the block times more little,
Oh, okay, I see.
the block can be made more speedily. It can solve this problem.
Oh, right, okay, I see.
In some degree.
Okay,
Yeah.
so it's really up to the community who participate to want to get this to be changed, so that front running, which is very quickly, definition of front running is where other people have access to the transactions that you have submitted, and then they can profit from knowing that. In the traditional stock markets, it's where insiders might have insider knowledge, and therefore they can profit. So that's an analogy, I guess. Right. So what you're saying is that the community will have to vote for a change to get the block time shorter and potentially eliminate or reduce that risk.
Make them have no time to send their transactions. Yeah.
Right, okay. Yeah, so thank you very much, Simon, for your time today. I learned a lot, and I hope our audience learned a lot as well. So thank you again for your time today.
Okay, thank you.